5.2, measurement of rotation. Your essential question, given an angle, how can you draw that angle, find its reference angle, and any coterminal angles? So let me start with the fact that we need to know what the standard position of an angle looks like. All right, so standard position of any angle, you're always going to start at the origin. So you're going to draw these things out on coordinate planes. Okay, where the vertex needs to be at the origin. So let's see, let's write a few bullet points here. So your vertex will always be at the origin. So let me label this the x and the y axis. The initial side is going to be on the positive horizontal or positive x-axis. And then we always measure counterclockwise. So for example, let's use this as my angle. Okay, so you can see that I've got a vertex here. This side right here is my initial side. This is my terminal side, where the angle ends. So the initial side and the terminal side make up the angle. And then the angle opens from this initial side, ends at the terminal side, and usually to represent an angle we use the Greek letter theta. Okay, so that's basically what any angle is going to look like. Now, we could have angles of varying degrees. Okay, so some examples of some angles. Might be, let's put an angle over here. Okay, so this angle could potentially be, well, it's more than 90 degrees, it's less than 180, so how about I say it's 135 degrees. Okay, angles can I mean, you can have angles as big as you like. That you could have an angle that goes around and around and around and around and it's thousands of degrees. I mean, just think of like figure skaters, right? When they do all their 360s, well, they could do like 1,000,000 360s and end up with, you know, however many degrees that ends up being. So a picture of that might look something like, and I won't go as crazy as some of the figure skaters that you see, but maybe the angle starts here and it goes around once, then twice, and maybe it stops here. All right, so let's think about what I've just done here. So let's pretend, let's see. So we went around one time, that's 360. I'll just write it down over here. Okay, we went around another time, that's another 360. And then let's pretend that I got back to that 135 degree mark again. So I went another 135 degrees, right? So altogether, well, I've got 720 plus 135, so that's 855. Right? So this is an 855 degree angle. Okay, and it can keep going. Now what happens if I go the opposite direction? So what if I go clockwise? So what if I decide I start here, and instead of going counterclockwise, I go this direction. So I go, let's say, to there. And these are always the x and the y axis, which I should be marking. Well, now I've gone in the negative direction, and let's pretend once again I've gone 135 degrees, but I've gone clockwise, so that's going to be negative 135 degrees. Next, we're going to talk about coterminal angles. So coterminal angles have terminal sides that coincide. they share a common terminal side, basically. So examples of terminal angles. Let's go ahead and do a couple of them here. All right, so maybe I give you, how about to make my life easy, how about we say that's a 60-degree angle? Well, then the coterminal angle with that would be the one that shares the common side but goes the opposite direction. So the coterminal angle would be negative 300 degrees. So coterminal angles are 60 degrees and negative 300 degrees. Let's see, let's just do one more for fun. Oh, what have I done? I'm sorry, I'm not paying attention. I'm paying attention to when the bell's going to ring. All right, this is X. This is Y. Sorry, let's do that one more time. X and Y. Okay. So let's try, let's start with a negative one. How about we go, we'll call that negative 120 degrees. Then the coterminal angle will start at the same point, okay? But now we're going to go counterclockwise, and we're going to meet at the same terminal side, leaving us with 240 degrees. So 240 degrees and negative 120 degrees. See how those add up to 360? Or any multiple of 360, really, because they could be even bigger. So actually, maybe I should show you one of those. Let's do one over here. So let's say I start with an angle that is 360, just to make this easy on myself, plus another 40 degrees right here. So I'm going to say that this angle originally was 400. So then what's a coterminal angle with this? Well, I mean, you could do this all day long. You could go back clockwise and go, you know, as many rotations as you want. But I could say that a coterminal angle then, if I start here and go back, and this is going to get us into our next definition. Well, this right here was a 40-degree angle, right? A reference angle. So just from the initial side up to the terminal side was really 40 degrees, even though I had an entire rotation in there. So that was really 360 plus 40 to give me 400 degrees. Well, then my coterminal angle starts at the same terminal side, goes clockwise now, meets up at that same terminal, starts at the same initial side, meets up at that same terminal side. So that's going to end up giving me, let's see, what is that? Negative 320. Okay, so this 400 degrees and this negative 320 degrees, you could consider those also coterminal angles. And I can have multiple coterminal angles. So I could add another rotation clockwise, which would be like adding another negative 360. So, you know, negative 680 could be another coterminal angle. Go around another time and add another negative 360. Next, we're going to talk about reference angles. And basically, the reference angle is the positive acute angle between the horizontal axis and the terminal side. Horizontal axis always being the x-axis. So, for example, let me go back and do that here too, x and y. That way it's really clear like where the angle is, where the coterminal side is. Oh, why don't we do, how about 100 degrees to make the numbers easy? So here's my 100-degree angle. Now your reference angle, basically you take that coterminal side and you draw an acute right triangle. So you draw a right triangle. So I'm going to bring this side down, and it's this acute angle right here that touches both the horizontal axis or the x-axis and the terminal side. So here my reference angle is going to be 80 degrees. That's my reference angle. And you can have a reference angle in any of these quadrants, and I'll do more examples so that you understand. So let's do a couple of examples here. All right, so example 1. We're going to sketch some angles and calculate the measure of each reference angle, okay? So this is basically, if you want to look at the directions, they're on page 251. And we're basically going to sketch 4 different angles in standard position and calculate the measure of each reference angle. Okay, so the first one is going to be a 71-degree angle. So 71, these don't have to be perfect, okay? But it's going to be approximately here. This is 71 degrees. Now, if I'm thinking of the reference angle, again, I draw that perpendicular line down from that terminal side to the horizontal axis, and I figure out what this angle is. Well, this angle, the reference angle here, is actually 71 as well. Okay, so here the reference angle equals 71 degrees as well. That's not always the case, just usually when you're in the first quadrant. Okay, let's do, so that was a 71-degree angle. Let's do 133 degrees. So 133 degrees is going to be in the second quadrant, because if I go from the positive x-axis, opening counterclockwise, this gives me 90 degrees, so it's going to be a little bit further. So that's 133. Now my reference angle is this angle right here. And, I like to draw the right triangle. That way I know, okay, do I have an actual right triangle? Does this look like a right triangle where my acute angle is, touching the origin? Okay, or it's touching the terminal side and the horizontal axis. Okay, so the question is, what is this angle? Well, that's going to be 180 minus 133, right? Because an entire half rotation here would get me to 180. And I need to go back, because I've gone 133 to this terminal side. So what is that? Is that 47? So let me just write it down here. So reference angle equals 47 degrees. So you can see this isn't too challenging. Okay, let me get another piece of paper because I'm out of room because I'm doing a lot of drawing here. Okay, let's do 2 more angles. I think we're going to do one in every quadrant. Okay, the next angle we're going to do is 254 degrees. Well, this would be to 180, right? If I start here, that gets me to 180, so I need to go further. But this is 270, so that would be too far. So I know I'm here. I'm 254 degrees. Now thinking of my reference angle, I'm just thinking of this part. So the question is, 180 plus how much more got me to 254? What is that? 74 degrees? So your reference angle is 74 degrees. And again, one way to calculate that is to say, okay, well, I went 180 here. How much more do I need to get to 254? So 254 minus 180 would give you what this reference angle is. Okay, the last one's going to be in the fourth quadrant. And I highly recommend drawing these pictures every single time. It makes it so much clearer than just trying to figure out, well, what's the reference angle if I have a 254-degree angle? All right, so the next one's going to be 317. So we know that if I start here and go all the way around, that would get me back to 360. So I know I'm going to be somewhere past the 270 mark, somewhere in here. All right, so we're going to call that 317 degrees. So now the reference angle, you take from the x-axis, the horizontal axis, draw a line down to the terminal angle. That gives us a right triangle, and then we're looking for this angle. All right, so this is 317, but if I went all the way, it would be 360. So the question is, what is 360 minus 317? And that ends up giving us 43 degrees. So the reference angle is 43 degrees. Nothing too hard here, hopefully. Okay, we'll do one more example. Again, same page. So we're going to sketch an angle that is 4,897 degrees. And then we're also going to label what its reference angle is. Okay, so obviously this is more than one rotation. But how do I figure out how many rotations it is? Well, one rotation is 360 degrees, right? So if I have 4,897 degrees, ooh, let's use some unit analysis. And I know that one rotation is 360 degrees. Then basically I can just multiply, right? Some things reduce, so the degrees are going to reduce, and I'm going to be left with how many rotations I get. If you punch that into your calculator, you're going to get about 3.6027. Or sorry, 13.6027. I think that's not what I said before. So there are 13 whole revolutions and 0.6 of another revolution, or 0.6027 of another revolution. Well, how do I figure out how many degrees that is? Well, okay, let's see. I've got 0.6027 of a rotation, and I want to put that back into degrees. So I know that there's 360 degrees per one rotation. So if I multiply those, the rotations reduce, and I'm back to how many degrees there are, and that is 217 degrees. Okay, so let's not get too carried away with graphing or with drawing this, right? We don't need to show that we have 13 revolutions, okay? We just need to show how far where our terminal side ends up, right? Because if I really wanted to show this, you know, and sit there and do this like 13 times, that's going to make my graph or my drawing a total mess. So I think the easier and neater way to do that is to say the terminal side is at 217 degrees, which is somewhere over here, right? So I've got a 217 degree angle there. That's drawn enough, okay, because I've shown where I've gotten the 217 degrees from. I know that it's 13 revolutions. Now what's my reference angle? Okay, reference angle is going to be this angle right here, right? Draw that side of my right triangle down. And the question would be, well, 180 plus what would give you 217 degrees? And the answer to that is, I believe, 37 degrees. Okay, and that would be your drawing.